Let us discuss about interquartile range and quartile deviation. The quartile deviation is one of the method of studying the dispersion or the difference of the values or the items which were given in the frequency distribution or in the series by eliminating 20, the lowest 25% from the highest 75% of items in a series. Then we are left with the central value or the central 50% which are ordinarily free of extreme values, and to obtain a measure of variation, we use the distance between first and the third quartiles, that is interquartile range. So therefore interquartile range is the difference of upper quartile and its lower quartile. So therefore interquartile range is equal to q3 minus q1. Then come to the meaning of quartile deviation. Quartile deviation, it is also called as semi interquartile range, and it is one of the most important the method of studying dispersion, and it is the average and the difference of average and the difference of upper quartile and lower quartile is called as semi interquartile range or quartile deviation. So the uh, and here the formula to calculate quartile deviation or semi interquartile range is equal to q3 minus q1 divided by 2. q3 minus q1 divided by 2. q3 is the upper quartile and q1 lower quartile, divided by 2. q3 minus q1 by 2, because it means that the average and the difference of upper and lower quartile is called as quartile deviation in semi inter quartile range or quartile deviation. And here quartile deviation is an absolute measure of dispersion. The relative measure of dispersion is known as the coefficient of quartile deviation. So therefore coefficient of quartile deviation is equal to q3 minus q1 divided by q3 plus q1. Interquartile range is equal to q3 minus q1. Quartile deviation or semi interquartile deviation or semi interquartile, the range is equal to q3 minus q1 divided by 2. Now quartile deviation is an improved measure over the range, because it is in range. The range is because quartile deviation is not calculated from the extreme the items. Therefore quartile deviation is most the important the method of studying dispersion over the range. Now computation of quartile deviation. So quartile deviation can be calculated under three aids. They are individual series, discrete series, and continuous series. So here uh, uh, for computation of quartile deviation for discrete series, means individual observation. So for computing quartile deviation for individual observation or for individual series, it is necessary that the data should be arranged in the ascending or descending order. So as in the case of calculation of median, the value of median, both in the case of individual observation as well as the discrete series, first the given data should be arranged either in ascending or descending. So like that, here also we have to arrange the given data in ascending or descending order. If it is given if it is given in proper manner, then we can straight away we can calculate value of quartile deviation. So the formula used for quartile deviation is equal to q3 minus q1 by 2, the average and the difference of upper and the lower quartile. So interquartile range is equal to q3 minus q1, and the coefficient of quartile deviation is equal to q3 minus q1 by q3 plus q1, and q1 and q3 can be calculated using the formula q1 is equal to n plus 1 by fourth item, where q3 is equal to 3 into n plus 1 by fourth item. Therefore, coefficient of qd is equal to q3 minus q1 by q3 plus q1. Here uh, we are going to solve the problem. The problem: calculate quarter deviation and its coefficient of runs scored by a batsman in a cricket matches. So 20, 28, 40, 12, 30, 15 and 50. So here the runs scored by a batsman is given here. We have to calculate quartile deviation and its coefficient of the quartile deviation. As the first step is that the data should be arranged in ascending order. So usually we arrange the data in ascending, uh, that is from lowest to highest, 12, 15, 20, 28, 30, 40 and 50. Now we have to calculate q1 and q3, lower quartile and upper quartile. Q1 can be calculated using the formula n plus 1 by fourth item. N is equal to, n stands for number of observations or number of items. Here n 7 items are given, or there are 7 items in the series. 7 plus 1 by fourth, therefore 7 plus 1 is equal to 8 by 4, therefore 4 ones are 4 twos are 8, therefore second item. So second second item in the given uh, the series is 15. 15 runs scored by a batsman. Therefore, Q1 value, the value of Q1 is equal to 15 runs. Similarly, Q3 can be calculated using the formula Q3 is equal to 3 into n plus 1 by fourth item. Therefore, Q3 is equal to 3 into n, already know the number of items or observations 7. 3 into 7 plus 1 by 4. 3 into 8 by 4. 4 ones are 4 twos are 8, therefore 3 into 2 is equal to 6. Therefore sixth item here 40. Sixth item 40, therefore 40 runs. Therefore quartile deviation can be calculated using the formula qd is equal to q3 minus q1 by 2, 40 minus 15 by 2, therefore 25 by 2 is equal to 12.5 runs. Similarly, formula to calculate coefficient of quartile deviation is coefficient of qd is equal to q3 minus q1 by q3 plus q1 is equal to 40 minus 15 divided by 40 plus 15, which is equal to 25 by 55 is equal to 0.4545. This is what the values of qd and its coefficient of qd. Now take another problem to clearly understand the calculation, the method of calculating QD and its coefficient of quartile deviation for both individual series, discrete series, as well as continuous series. Interquartile range, we have to calculate the data given below. Calculate interquartile range, quartile deviation, and coefficient of quartile deviation. So here uh, we should here we have to ensure that whether the given data is in ascending order or descending order. First we should ensure that so if it is given in more proper way, either in ascending or descending, we can directly go for solving QD and its coefficient of quartile deviation. So 8, 10, 14, 22. Here the values are given in ascending order. So therefore no need to arrange, because already it is in ascending order. So therefore the data is given in ascending order. So in order to calculate q1 is equal to n plus 1 by fourth item. N number of items or observations 11. 11 plus 1 by fourth is equal to 12 by 4. Therefore 4 ones are 4, 3s are 12. Therefore third item is equal to 14. Now calculate q3. q3 is equal to 3 into n plus 1 by fourth item. 3 into 11 plus 1 by 4 is equal to 3 into 12 by 4 is equal. Therefore 4 ones are 4, 3s are 3 into 3 is equal to 9. Ninth item. So here find which is the ninth item. So ninth item is 44. So here after finding the values of q3 and q1, apply the formula. Interquartile range is equal to q3 minus q1. Substituting these values into the formula, 44 minus 14 is equal to 30. Therefore interquartile range is equal to 30. Now quartile deviation can be calculated using the formula qd is equal to q3 minus q1 by 2. Upper quartile minus lower quartile divided by 2 means what? 75% minus 25% divided by 2. So 44 q3 minus 14 q1 divided by 2 is equal to 30 by 2 is equal to 15. Now coefficient of quartile deviation can be calculated using the formula. Coefficient of qd is equal to q3 minus q1 by q3 plus q1 is equal to 44 minus 14 divided by 44 plus 14 is equal to 30 by 58 is equal to 0.517. This is what coefficient of quartile deviation. Now computation of quartile deviation for discrete series. So for discrete series, for computing quartile deviation for uh, discrete series, it is necessary that the data should be arranged in ascending or descending order. So already this is already you know that. So the formula used for quartile deviation is equal to q3 minus q1 by 2. So interquartile range is equal to q3 minus q1 by coefficient of qd is equal to q3 minus q1 by q3 plus q1. Now calculate semi interquartile range and quartile deviation from the following. Here age in years plus number of members are given. Age in years is to be treated as the values, and number of members are considered as frequency. Age in years x ಆಗಿರಲಿ and number of members f ಆಗಿರಲಿ ಅಂತ ತಗೊಂಡಿದ್ದೀವಿ ಇಲ್ಲಿ. ಮೀನ್ಸ್ x and f ಕೊಟ್ಟಿದ್ದಾನೆ. ಎಕ್ಸ್ ಅಂದರೆ ವ್ಯಾಲ್ಯೂಸ್, ಎಫ್ ಅಂದರೆ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಎಕ್ಸ್ ಮತ್ತು ಎಫ್ ಕೊಟ್ಟಾಗ ಅದನ್ನು ನಾವು ಡಿಸ್ಕ್ರೀಟ್ ಸೀರೀಸ್ ಅಂತ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಸೊ ವೆನ್ ಅಂಡರ್ ಡಿಸ್ಕ್ರೀಟ್ ಸೀರೀಸ್ ಬೋತ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಪ್ಲಸ್ frequencies are given. Now age in years x, number of members f. Therefore While calculating quartile deviation under discrete series, the first step is to arrange the given data in ascending order. This is to be first we have to ensure that this is the first thing in which we should ensure that whether the given the values are in ascending or descending. ಕೊಟ್ಟಿರುವಂಥ ವ್ಯಾಲ್ಯೂಸ್ ಅಸೆಂಡಿಂಗ್ ಅಲ್ಲಿ ಇದೆಯಾ ಅಥವಾ ಡಿಸೆಂಡಿಂಗ್ ಅಲ್ಲಿ ಇದೆಯಾ ಅನ್ನೋದನ್ನ ಫಸ್ಟ್ ನಾವು ಎನ್ಶೂರ್ ಮಾಡ್ಕೊಳ್ಬೇಕು. ಕೊಟ್ಟಿಲ್ಲ ಅಂತಂದಾಗ ನಾವು ಅಸೆಂಡಿಂಗ್ ಮಾಡ್ಕೊಳ್ಬೇಕಾಗುತ್ತೆ. ಇನ್ ಕೇಸ್ ಇಫ್ ಇಟ್ ಈಸ್ ಗಿವನ್ ಇನ್ ಪ್ರಾಪರ್ ವೇ, ಇಫ್ ಇಟ್ ಈಸ್ ಗಿವನ್ ಇನ್ ಅಸೆಂಡಿಂಗ್ ಅಥವಾ ಡಿಸೆಂಡಿಂಗ್ ಕೊಟ್ಟಾಗ ಡೈರೆಕ್ಟಾಗಿ ಕೊಟ್ಟಿದ್ದಾನೆ ಅಂದಾಗ ನಾವು ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡಿ ಡೈರೆಕ್ಟಾಗಿ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. ಸೊ ಎಕ್ಸ್ ಅವನೇ ಕೊಟ್ಟಿದ್ದಾನೆ, ವ್ಯಾಲ್ಯೂಸನ್ನು ಅಸೆಂಡಿಂಗಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾನೆ. ನೆಕ್ಸ್ಟ್ ಯು ಟೇಕ್ ಎಫ್. ಎಫ್ ಫ್ರೀಕ್ವೆನ್ಸಿ, ಎಫ್ ಅಂದರೆ ಫ್ರೀಕ್ವೆನ್ಸೀಸ್ ಅಂದರೆ ನಂಬರ್ ಆಫ್ ಮೆಂಬರ್ಸ್ ಕೊಟ್ಟಿದ್ದಾನೆ. ಆ್ಯಂಡ್ ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್ ಈಸ್ ಟು ಕನ್ವರ್ಟ್ ಎಫ್ ಇಂಟು ಸಿ ಎಫ್. ಎಫನ್ನು ನಾವು ಸಿ ಎಫ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಮಾಡಬೇಕು. ಸೊ ದಿಸ್ ಇಸ್ another the important the second important step is to convert frequencies into cumulative frequencies. 3 3 ಬರ್ಕೊಳ್ತೀವಿ. 3 ಪ್ಲಸ್ 61 64, 64 ಪ್ಲಸ್ 132 196, 196 ಪ್ಲಸ್ 153 349, 349 ಪ್ಲಸ್ 140 489, and 489 plus 51 540, 540 plus 3 543. So after converting f into cf cumulative frequencies, then find q1 and q3. So already you know how to calculate q1 and q3. So q1 is equal to n plus 1 by 4th. N means total frequency. This is another the thing in which you should keep in mind that except in the case of individual series, n is equal to ಇಂಡಿವಿಜುವಲ್ ಸೀರೀಸ್ ಬಿಟ್ಟರೆ ಇನ್ನು ಬೇರೆ ಕೇಸಸ್ ಎಲ್ಲವೂ ಕೂಡ ಎನ್ ಅಂದರೆ ಟೋಟಲ್ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಎನ್ ಇಸ್ ಇಂಡಿವಿಜುವಲ್ ಸೀರೀಸಲ್ಲಿ ಮಾತ್ರ ಎನ್ ಸ್ಟ್ಯಾಂಡ್ಸ್ ಫಾರ್ ನಂಬರ್ ಆಫ್ ಐಟಮ್ಸ್ ಆರ್ ನಂಬರ್ ಆಫ್ ಅಬ್ಸರ್ವೇಷನ್ಸ್. ಸೊ ಇಲ್ಲಿ ಎನ್ ಅಂದರೆ ಟೋಟಲ್ ಫ್ರೀಕ್ವೆನ್ಸಿ 543 ಪ್ಲಸ್ 1 by 4th, 544 by 4. Therefore 544 divided by 4 means 136. So 136th item. So 136th item, this is what the calculated value. So calculated value 136, and then we should find out that where it falls in ಸಿ ಎಫ್ ಕಾಲಮ್. ಸಿ ಎಫ್ ಕಾಲಮಲ್ಲಿ ಎಲ್ಲಿ ಬರುತ್ತೆ ಅನ್ನೋದನ್ನ ನೋಡ್ಕೊಬೇಕು ನಾವು. 136 ಎಲ್ಲಿ ಬರುತ್ತೆ? ಸೊ 136 ವಿಚ್ ಫಾಲ್ಸ್ ಇನ್ 196 ಸಿ ಎಫ್. ಸೊ ಎಗೇನೆಸ್ಟ್ ಟು ದಟ್ ಸಿ ಎಫ್ ಈಸ್ ನೋನ್ ಆಸ್ ದಿ q1 value, that is 40. So therefore q1 is equal to 40 es. So likewise q3 is to be calculated as 3 into n plus 1 by 4th. 3 into 543 plus 1 by 4 is equal to 3 into 544 by 4. Therefore 3 into 136 is equal to 408. So 408 where it falls in CF column. So 408 which falls in 408 which falls in 489 in CF column. ಸೊ ದೇರ್ ಫೋರ್ 489 ಅಲ್ಲಿ ಬರೋದ್ರಿಂದ ನಾವು ಅದರ ಎಗೆನೆಸ್ಟ್ ಆಗಿರ್ತಕ್ಕಂಥ ವ್ಯಾಲ್ಯೂ ಯಾವುದು ಅನ್ನೋದನ್ನ ನೋಡ್ಕೊಳ್ಬೇಕು. ಅದರ ಎಗೆನೆಸ್ಟ್ ಆಗಿರುವಂಥ ವ್ಯಾಲ್ಯೂ 60. ಆ 60ಯನ್ನು ನಾವು q3 ವ್ಯಾಲ್ಯೂ ಅಂತ ನಾವು ಕರಿತೀವಿ. ದೇರ್ ಫೋರ್ 60 ಇಯರ್ಸ್. ನಾವು qd is equal to q3 minus q1 by 2, the average and difference of upper quartile and lower quartile. 60 minus 40 divided by 2 is equal to 20 by 2 equals 10 years. This is what the value of quartile deviation. Now Coefficient of quartile deviation is equal to q3 minus q1 by q3 plus q1. 60 minus 40 by 60 plus 40 is equal to 20 by 100 is equal to 0 0.2. 0.2 is known as the value of coefficient of quartile deviation. Now, from the data, calculate interquartile range, semi-interquartile range, uh, also known as quartile deviation, and coefficient of quartile deviation of the marks of the students. So marks values ಕೊಟ್ಟಿದ್ದಾನೆ, ಹಾಗೇನೆ number of students frequency ಕೊಟ್ಟಿದ್ದಾನೆ. So this is the problem of quartile deviation for a discrete series. So from this data we have to calculate qd and its coefficient of quartile deviation. So first the values are to be taken in the first column, and frequencies are in second column. Marks f. ಸೊ ಕೊಟ್ಟಿರುವಂಥ ವ್ಯಾಲ್ಯೂಸ್ ಅಸೆಂಡಿಂಗ್ ಅಲ್ಲಿ ಇದೆಯಾ ಇಲ್ವಾ ಅಂತ ನೋಡ್ಕೊಳ್ಬೇಕು. ಸೊ ದಿಸ್ ಇಸ್ ದಿ ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಇನ್ ವಿಚ್ ವಿ ಶುಡ್ ಎನ್ಶೂರ್ ದಟ್ ವೆದರ್ the given values are in ascending or not, ascending or descending or not. ಕೊಟ್ಟಿರುವಂಥ ವ್ಯಾಲ್ಯೂಸ್ ಅಸೆಂಡಿಂಗ್ ಅಲ್ಲಿ ಇದೆಯಾ ಅಥವಾ ಡಿಸೆಂಡಿಂಗ್ ಅಲ್ಲಿ ಇದೆಯಾ ಅನ್ನೋದನ್ನ ಫಸ್ಟ್ ನೋಡ್ಕೊಳ್ಬೇಕು. ಸೊ ಇಯರ್ ದ ವ್ಯಾಲ್ಯೂಸ್ ಆರ್ ಗಿವನ್ ಇನ್ ಅಸೆಂಡಿಂಗ್, ದೇರ್ ಫೋರ್ the second we are going to uh, uh, the second the step of converting frequencies into cumulative frequencies. ಸೆಕೆಂಡ್ ಸ್ಟೆಪ್ ಹೋಗಬೇಕು. ಎಫ್ ಅನ್ನು ಸಿ ಎಫ್ ಮಾಡ್ಕೊಳ್ಬೇಕು. 10 ಫಸ್ಟ್ 10 ಬರ್ಕೊಳ್ತೀವಿ. 10 ಪ್ಲಸ್ 12 22, 22 ಪ್ಲಸ್ 14 36, 36 ಪ್ಲಸ್ 9 45, 45 ಪ್ಲಸ್ 10 55, 55 ಪ್ಲಸ್ 11 66, 66 ಪ್ಲಸ್ 12 78. ಸೊ ಈ ಥರ ನಾವು ಸಿ ಎಫ್ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗ್ತೀವಿ. ಸೊ ಆಫ್ಟರ್ ಕನ್ವರ್ಟಿಂಗ್ ಎಫ್ ಇಂಟು ಸಿ ಎಫ್, ದೆನ್ ಫೈಂಡ್ ದಿ ವ್ಯಾಲ್ಯೂಸ್ ಆಫ್ q1 and q3. q1 is equal to n plus 1 by 4th. n is equal to total frequency 106 plus 1 by 4. Therefore 107 by 4 is equal to 26.75. 26.75 where it falls in CF column. So 26.75, this falls in 36 CF. Therefore q1 value is equal to 52 marks, and then calculate q3. q3 is equal to 3 into n plus 1 by 4th. 3 into n, total frequency 106 plus 1 by 4, 3 into 107 by 4. Therefore 3 into 26.75 is equal to 80.25 item. So therefore we have to ascertain that where it falls in CF column. So in CF column it lies in 89 CF. Therefore against to that the value is 57. Therefore 57 marks is the q3 value. Now interquartile range can be calculated using the formula q3 minus q1 is equal to 57 minus 52 is equal to 5. So therefore 5 is the value of interquartile range. Semi-interquartile range or quartile deviation can be calculated using the formula qd is equal to q3 minus q1 by 2. 57 minus 52 by 2 is equal to 5 by 2 equals 2.5 marks. And then coefficient of quartile deviation can also be calculated using the formula coefficient of qd is equal to q3 minus q1 by q3 plus q1 is equal to 57 minus 52 by 57 plus 52 is equal to 5 by 109 is equal to 0.0458. This is the value of coefficient of qd, and the value of qd is equal to 2.5 marks. So therefore this is the way and the method of calculating the values of interquartile range, semi interquartile range, or quartile deviation, and coefficient of quartile deviation.